Well, welcome back. Today we're going to be talking about analyzing impulse, specifically with graphs. Today you're going to learn how to relate momentum to y equals mx plus b, an eighth grade equation, correlate momentum and force, and I don't think we're going to quite get to being able to discuss how collisions and how momentum is conserved. Okay, here's our first equation. This looks a lot like either a graph you have seen or you're going to see when we talk about impulse. What I want to show you with this then is there's really two things you can do with equations if you're going to analyze them. First, you can find the slope by dividing the x and y components. And in this case, that would be force divided by time. And that's not really anything that we want to do right now. So the slope with force and time doesn't really give me anything. So the other thing I automatically start to look for then is what happens if I multiply them. What if I find the area? And in this case, if I take my x and y axes and multiply them, well, hey, that gives me something we've talked about quite a bit in class, and that would be impulse. In this case, then, what we find out is the area underneath this curve, the area underneath here, all of this area right here, this area is equal to the impulse. Now, what I want you guys to understand is that we have a couple equations for impulse. Just like we have a couple equations for acceleration that you guys have used quite often, we've got a couple equations for impulse. One is this one, impulse equals force times time. But we also have change in momentum equals impulse, which means mvf mvi, the final momentum minus the initial momentum, that's the change in momentum, is equal to the impulse. Well, if this is equal to impulse and this is equal to impulse, then what we can say is that the force times time is equal to mvf minus mvi. And in several occasions, what we're going to find out is the initial momentum is equal to 0, so it goes away. Not always, but sometimes this right here is going to go to 0. So you're left with just force times time equals the final momentum. So we were talking about correlating momentum and force. Well, sometimes a very simple mistake, sometimes you see students, is they want to, all right, choose it here. I can't get it to quite go away. There we go. Quite often what they want to do is they want to say that you ask them for momentum and they give you ma. Or if you ask them for force and they give you mv. Well, that's not right. All right, they're very similar. Momentum is mass times velocity, and force is mass times acceleration. Now, we just kind of let the hat out of the bag. The way these two equations are related, they're related by impulse. And what that means is that force times time equals as the equation we've given. So they're not the same, but they are related to each other by this equation. And what you really find out here is a couple things you can do. This right here, remember, stands for change in momentum. The force, if I have a big engine behind a car, it's going to cause a big change in momentum. It's going to allow it to go very fast. Likewise, I can have a small engine, but have the accelerator down for a long time, and that can also change the momentum. Now, we're not talking about acceleration. We're just talking about the change in speed here of this object. All right, let's look at a different equation here now with impulse. And I've got it written up here a little bit funky, but really it's just I equals ft. And in this case, what I want you to see is I'm telling you that over here is our impulse, and down here is our time. We talked about there's two things you can always do. You can find the area by multiplying them, and that would be I times t. And other than it spells the word it, I don't know anything else that's impulse times time. What I do know is if I divide them, All right, if we divide them, that gives me the slope. And again, now impulse over time is going to be equal to the force, which means that the slope in this case is force. So whenever you get a graph, you need to ask yourself, check these two things. Does slope give me anything? Remember, that's when we divide. And then the other thing we want to find out is, does the area give me anything? And that's when we multiply the two components. Sometimes it gives, slope is almost always can be found, and area can almost be found, but not always in the same graphs. There's very few that I can think of that you can find slope and area, and it's going to give you something that's of use. Again, in this, and it's the easiest way is just to write them out, like I did here. To find slope, I said, okay, I'm going to check slope first, and I took impulse over time. Impulse over time gives me force. That is something that we deal with. All right, impulse over time is force. Area. What about impulse times time? Does that give me anything? No. So area on this problem is useless. Slope is good because it allows me to find the force. So in this case, if this was my equation, this 10,000, that would be telling me the force because I had impulse and time. Well, hey, hopefully this has been beneficial. I'll catch you on the flip side.